class, in today's video, we're going to be looking at linear inequalities. The learning intention of this video is we're going to know the meaning of the term inequality. We're going to be able to use and interpret the different inequality signs, to know how to interpret and represent an inequality on a number line, to understand when to reverse the sign in an inequality, and lastly, to be able to successfully solve a linear inequality. So first thing I want to do is I want to help define what an inequality is. So in this case over here, because we're looking at linear inequalities, okay, the word linear represents just any expression or an equation where x is raised to the power of 1, okay, so that would therefore produce a straight line. So that's what linear means. The prefix in would actually indicate not, so in means not, and therefore the equal part means not equal. So therefore a linear inequality, if you piece up these definitions together, a linear inequality is just a statement where it contains two linear expressions that are not equal to one another. And there are various inequality signs, and you should be familiar with these signs already from your previous years of study, okay? Now, there are two different types of linear inequalities that we're going to be looking at. There is the one variable linear inequality as well as the two variable linear inequality. Now, this used to be actually assessed in Maths A. However, because we're doing remote learning, we've decided to actually remove this. So don't worry too much about two variable inequality. It won't be assessed and we're not going to touch on it, but I'm going to just briefly mention what are the fundamental differences between these two. So one variable would indicate that it only contains one letter. So in this case over here, x is less than or equal to 7. That's an example of a one variable linear inequality. Whereas on the right hand side of here, I've got y is less than half x minus 2. It's an example of a two variable because a variable is a letter, so it contains two letters, as you can see here, y and x. And if you were to graph each of these over here, they actually produce very different types of graph. So for a one variable linear inequality, the way you'd graph this is through a number line, okay? So it's two-dimensional in this case over here. Whereas when you're drawing or producing a graph for a two variable linear inequality, you're going to be plotting this on a Cartesian plane, and this will produce a straight line, and you're going to have to shade relevant areas, but you don't have to worry about that at all. The reason why we actually care about inequalities is because we could actually use inequalities to model many things in real life. So I've got three examples over here. I've got the speed limit. So if you were to represent the speed limit as a linear inequality, you'd write something similar to this. You'd say x is less than or equal to 50 because you can't drive past 50 kilometers per hour. So therefore you can, as long as you're driving 50 or lower, then it's suitable. Similarly for, there's a height requirement. So for instance, if the height requirement is like, let's say 130 centimeters, then you could write this as you have to be at least 130, so you could be 130 on the dot or higher than that. Or similarly, this is like more for the olden days, but back in the days, you actually had a limit of how many text messages you could make if you're on a prepaid plan. So for instance, let's just say hypothetically, you could send no more than 200. So 200 was the maximum amount of text messages that you could make. What we're going to be looking at now is how do we actually interpret and make sense of a linear inequality, okay? And before I go through that, I must go through the definition of what the word solutions mean. So the word solution is just pretty much, it's any and all numbers that when plugged into the inequality or the equation, this will satisfy that particular statement, okay? So what I mean by that is if you actually sub it in, hopefully what it will give you is a true statement. So this is a statement that actually makes sense. So this number is definitely smaller than that number. That's reasonable. So let's look at an example to see what I mean by this. So the example reads, list three solutions that holds true for the following linear inequalities. It's pretty much saying, well, give me three numbers that are bigger than 3, because this symbol here means it's greater than. Note that it's not greater than or equal to, so you have to find 3 random numbers that are bigger than 3. Obviously, there's going to be an infinite amount of numbers that are greater than 3, so I'll just say 4, 5, 6, but obviously any number bigger than 3 is a solution and it's a true statement for this particular problem over here, okay? And you can kind of see this on a graph if I was to actually draw this as well. So any number larger than 3 is going to be an answer or a solution. What I want you to do right now is I want you to have a go. So give me an example of a number that satisfies this particular problem over here, okay? So give yourself a minute and then compare your answers with my answers. Now, if you've done this successfully, you could number it as -6, -7, -8. So obviously, the more bigger the negative number is, it's going to be much more smaller than -5. And this can also be represented over here on the number line just to show that as well. All right, guys, what I'm going to show you now on this particular slide is that for certain inequality problems, a solution for that particular problem may lie in between two values. Now, previously, if you see, as you can see over here, I've drawn an arrow that indicates that it kind of goes to negative infinity in this case over here. So there is a large range of solutions that satisfy this particular problem. However, in this slide over here, I'm saying that in certain problems, it can only lie within a smaller range, okay? So we're not going to draw like those humongous arrows. So I'll give you an example to show you what I mean. So it reads, the temperature is greater than -4 degrees Celsius and less than 12 degrees Celsius. What I'll do is I'll break this up into two little statements over here. So the temperature is greater than -4. I can write that as x is greater than -4 as shown over here. And to show that x is less than -12, I could write that as x less than 12, okay? Pretty straightforward. But what you could do in this case, because the temperature lies between these numbers over here, I can rewrite this in a simpler way in one single statement. I can rewrite this as this, and this pretty much means the exact same thing. This says x over here, -4 is smaller than x, so therefore that means x is bigger than -4 degrees, but x is less than 12 degrees Celsius. That's what that statement here means. So the way that you'd write this is for the bigger number, you pretty much keep this as it is, so that's why this stays the same. But as you can see here, what I've done is I've pretty much flipped it, because this is still the exact same thing. I could still say -4 is smaller than x, and that's the same thing as saying x is bigger than -4. And because they mean the same thing, what I could do is I could flip that sign, and therefore this, I could rewrite it in this format over here, okay? And as such, solutions that will satisfy this particular inequality would therefore include these numbers here. You can choose any numbers. These are all solutions for this particular problem over here, okay? 12 should not be included at all. My bad, I just realized that, because it's less than 12 degrees, so 12 is not included at all. What I want you to do now is I want you to have a go with answering these questions over here. So pick any three numbers that will satisfy each of these particular problems. Have a go and then compare your answers. If you guys have done this successfully, then you could choose any three solutions from the list down below. So hopefully you guys got this right. It's not too hard yet. We're going to be moving on to the next part of today's lesson, okay, which is about representing these linear inequalities on a number line. So how do we actually do this? What you need to know is like pretty much the symbolic notations that we use to actually represent this. So we use circles and arrows to represent solutions on a number line, okay? Now, note over here that we use an open circle, meaning like an empty circle in this case, when you have the less than or greater than symbol, okay? In contrast, we use a closed or a shaded circle when there is a less than or equal to symbol, or a greater than or equal to symbol, okay? Because this line over here pretty much means equal, that's why we include it, which is why we actually shade it. That's why this circle is shaded. So as you can see over here, if I was to represent x is less than 5, this is what it would look like, okay? This is what it would look like if it was saying x is greater than 5. Notice that for both of these examples over here, the circles are not shaded because 5 is not included. But for the examples down below, because 5 is included for both of these, then you will need to include a shaded circle as shown over here. Now, what you might have realized is in these examples is that the direction of the inequality is always going to be somewhat in the same direction as the direction of the arrow, okay? So look over here, notice that this points that way, notice that this arrow also points in the same direction, and this pretty much applies for all of the examples shown on this particular slide over here. So as you can see, this points to the left-hand side for the examples on the left, on the examples on the right, it points to the right, okay? Now, the reason why I've actually included this as asterisk is because this is true, but you need to know when this doesn't actually work, and I'm going to go through that I think towards the end of the slide, so please stay tuned then to find out when can't you actually use this, okay, or when to be mindful. So in this case over here, again, I'm going to show you what would this look like for a inequality problem where the solution is between two values, okay? So again, remember, we're going to be using these empty circles when you've got the less than or greater than sign, but you're going to be using a shaded circle when you've got the equal inequality symbol. So the example reads x is greater than or equal to -1 but smaller than 3. Okay, so in this case over here you could write this first part as being x is greater than or equal to -1 as such. You could write x is smaller than 3 like this, x is less than 3, and therefore if because 3 is a bigger number, if we're trying to write this as one single statement, you leave this as it is, but you have to flip this particular sign over here just to make it a true statement. So therefore you'd write it as -1 is less than or equal to x, which is less than 3. Okay, and again, as I said, these two statements are the exact same thing because they're true statements. And therefore, as you can see down below, the way that we actually represent this is going to be a bit different from the other examples that we've actually covered, okay? So in this case, when you've got a solution that lies in between two values, this over here, this symbol would indicate that we're going to have to use an empty circle, which is shown over here. And therefore, because -1 is included, I am going to have to shade it in the circle where it's at -1, okay? Notice that we're not using arrowheads like something like this over here at all, because it doesn't go on to -infinity or positive infinity. Because it lies in between two values, no arrowheads are used at all. And therefore, on this particular slide, I'm just showing you another example over here. I've already covered through this example, but if you wanted to look at another example, this is how you'd actually show it with this particular scenario over here. This is pretty much a summary. I'll post a nice poster that kind of summarizes what we've just covered through, okay? So you can copy this into your exercise book if you find this helpful. Otherwise, I'm going to get you to now answer this question. So give yourself 2 minutes. What you want to do is you want to match these three with one of the graphs down below. Have a go and then compare your answers. All right, guys. Now for the very first one, it reads that x is greater than 2. So try to find one that is where x is positioned onto. In this case, it makes sense that A is going to be where C is. For B, in this case, x is less than or equal to -2. In this case, the only suitable option is going to be A. And notice again that this points into the direction where the arrow goes. Now C is where you it's saying that the solution lies between two values, which therefore is going to be B in this case over here. All right, we're going to be looking at how do we actually solve linear inequalities, okay? So the way that we actually solve linear inequalities pretty much follows the exact same rules as we use to solve just regular linear equations, okay? So we're going to be using the FUCK method regardless. However, the only difference is that because an inequality sign is involved, when you actually multiply or divide by a negative number on both sides of the equation, what you need to do is you actually need to flip or reverse the inequality sign. And I'm going to show you a few examples to show you what I mean by this. So let's look at the first example over here. It reads 2x minus 5 is less than 1. Okay, so we're going to be using the FUCK method. So what I want to do first is I'm going to I'm going to move this -5 over here by using inverse operations. So I'm going to add 5 to both sides of the equation, okay? So if I add both sides to the equation, because these are inverses, this cancels each other out. So therefore, I'm going to be left with 2x is less than 1 plus 5, which is equal to 6, okay? And now last step is I have to kick away the coefficient being 2. So I'll divide both sides by 2. X is therefore going to be 3. So and notice I said equals 2, but it should be x is less than 3, okay? And in this example of here, because I haven't multiplied or divided by a negative number on both sides of the equation, I'm going to leave the inequality sign as it is, okay? And if I was to try to show you the solution diagrammatically, then this is what it would look like, because we've already covered this. Now I want to show you another example, and in this particular example up here, this is where the inequality sign will actually flip, okay? So in this case over here, I'm going to do the exact same process as before. I'm going to eliminate the positive 5 by subtracting by 5 on both sides of the equation. If I subtract 5 on both sides of the equation, this will eliminate this. So therefore, on the left-hand side, I'm left with just 3x. On the right-hand side, I'm going to get -21. Now, to isolate x, I have to divide both sides by -3, the coefficient. And if I do this, as I said earlier on, when we divide both sides or multiply by a negative number, we need to change the direction of the inequality. So in this case over here, instead of a less than sign, we're going to change this to a greater than, and we know that two negatives cancel each other out. 21 divided by 3 is equal to 7. And therefore, if you were to draw this diagrammatically on the number line, then this is what it's going to look like, okay? So now notice that in this particular case over here, although although the inequality sign is a less than sign over here, one would assume that when you're drawing the arrow, it would look something similar to this over here. But in this case over here, that's not the case at all. That's why I told you to be wary before, okay? So in this case, once you finally solved it, it's only then you look at the final answer, and whatever the direction of that inequality is, that's going to be the direction of your arrowhead, okay? So I'm going to be explaining why is it that we actually flip the actual inequality sign when you multiply or divide by a negative number. So let's just use this very simple example over here, just so you can wrap your head around it. So let's take 1 is greater than 0 as an answer, okay? Now, if you ask yourself, is 1 a bigger number than 0? You'd probably say, yes, 1 is a bigger number than 0. Duh, everyone knows that. So this is a true statement, okay? Now, what I'm going to do is I'm just going to multiply both sides by -1, okay? Now, we know that -1 multiplied by 1 is going to give you -1. 0 multiplied by -1 is equal to 0, okay? Now, in this case of here, I'm not going to flip the inequality sign because I want to show you why it is we actually flip it. Now, just read it to yourself and ask yourself, does this statement make sense at all? Is -1 a bigger number than 0? Obviously, your 200 IQ would say that this is not the case at all. So therefore, this is not a true statement. How can we make this a true statement then? Well, we can only make this a true statement if we actually just reversed or flipped the direction of the inequality sign. So therefore, if you were to flip it and now it's -1 is less than 0, this is now a true statement because -1 is a smaller number. So hopefully through this example, you can kind of see why we actually flip it. We flip it so that the statement makes sense. Alright guys, what I want you to do right now is using the examples I've shown you previously, have a go with answering this question over here. So give yourself 3 minutes and then compare your answers with my answers. If you guys have done this successfully, what you would have done is that we're going to keep x to the left-hand side of the equation. So what I'll do is I'm going to get rid of this 7x found on the right-hand side by subtracting this by 7x. Whatever I do to one side, I must do to the other side. So that cancels that out. Notice that you've got a positive 1 on the left-hand side. So to get rid of that, I'm going to subtract both sides by -1, okay? Now, my working out looks messy, but that's kind of shown over here. These over here are inverses, so 1 take away 1, they cancel each other out. 7x take away 7x cancels each other out. So now if I simplify this, 4x take away 7x, that gives me -3x, and that's going to be greater than -3. What I'm going to do right now is I'm going to divide both sides by the coefficient. In this case, that's going to be 3. So if I divide both sides by 3, I'm going to get an answer of -1. Notice again, I'm not flipping the equation because I'm not dividing or multiplying by a negative number, okay? Lastly, I'm going to just quickly go over again, how do we actually graph these linear inequalities after we solve it? So before, as I said, I just want to emphasize the point that do not assume that the direction of the inequality sign in the original question or in the original problem will equal or correspond to the direction of the arrow which you draw towards the end. So this was an example that we looked at previously before. In this case of here, once you solved it, we said that x is greater than -1, and only then when you actually solve it, then you could follow the inequality sign as shown over here. So therefore, if I was to plot this, it would look something similar to this. And notice that this direction aligns with this arrow here. I want to show you another example where this is not the case so that you don't make these assumptions at all. So in this case, 4 minus 6x over 9 is less than 2. What you would do is you would make sure that they'll have the exact same common denominator. So in this case, I'm going to multiply this numerator and denominator by 9 on 9, okay? And if I do this, therefore, I'm going to get 18 on top. And because the denominators are the same, I pretty much ignore the denominators, okay? What I'll do next is I'm going to remove the 4 by subtracting 4 to both sides. So if I subtract 4 to both sides, these are inverses, so they cancel each other out. I'm going to be left with -6 is less than 14, okay? Divide both sides by -6. Remember, when I said we divide both sides by a negative number, we have to change the direction of the inequality sign. And if you simplify 14 with 6, that's going to give you -7/3. Notice that we don't have a nice whole number, but sometimes in maths, you don't actually get these nice numbers. That's pretty much very similar to -2.33, if I'm correct. So if I was to pretty much draw this on the number line, this is what it would look like over here. Now, again, just to emphasize, this over here is what we look at. We don't really look at the inequality sign at the original question when we're actually graphing it, okay? So because it's going in this direction, that's why my arrowhead also follows the exact same direction as well. And that's pretty much summarized in that little speech bubble down below. What I want you guys to do right now is I want you to answer these questions over here. So I want you to answer questions 1, questions 2, questions 3, as well as question 4 and 5, okay? And if you do this, then you should have a great understanding of how you solve linear inequalities and be able to actually represent them on a number line. So hopefully you guys are able to address the success criteria. Thank you for watching today's video. I'll see you guys again in the next video. Bye.